Hey everybody, we're going to go over the fifth lesson of Unit 4 today. This is dividing rational expressions. We are going to take 2 days in class to do this, so I'm going to stop at the end of day 1 for this one, and then the next video will be the day 2. At the top up here, we have dividing rational expressions is almost the same thing as multiplying rational expressions, except when dividing, you must multiply by the reciprocal, which you originally learned in numerical fraction operations, and it says Woo Middle School because that's when you learned how to do this. So up at the top here, we've got some practice numerical fractions. I'll do this one, then you can try the other two. This one right here, we have 1/4 times 3/2. When we are dividing fractions, what you're actually going to do is keep the first one, change to multiply, and do the reciprocal of the second, which means you're going to flip it over so that the denominator becomes the numerator and the numerator becomes the denominator. And then you're just going to multiply like normal. So you multiply across the top and across the bottom. You can also remember step 2 from last time is simplifying. These will both divide by 2. And then we'll multiply across the top. We get 1. Multiply across the bottom, we get 6. And that would be the answer. Okay, let's look at this one. I realized I didn't do any of these written vertically like this. This is how you'll see it much more often later on in pre-cal and college algebra. This is the same thing. This is just saying that this one is divided by that one, just like we have over here. Okay, so we keep the first one the same. We change to multiplication, and we do the reciprocal of the second. And then on this one, these will simplify. 10 divided by 10 is 1. 20 divided by 10 is 2. And then multiply across the top, we get 14. And across the bottom, we get 3. This last one here, we have a whole number. Remember, if you have a whole number, its denominator is going to always be equal to 1. So anytime you see just a plain old, I was going to zoom out to a number, but we don't have one. Anytime you see a plain old number, its denominator is 1. If you see something that doesn't have a denominator, its denominator is 1. We should always write it down. So we're still going to keep the first one, change to multiply, and flip the second, or multiply by the reciprocal. 8 times 6 is 48 over 1, which is just 48. Remember, you don't have to write down a denominator of 1. Good. Hopefully that little review helped. And now we're going to try these. Same thing as multiplying after you've changed the second one to the reciprocal, then it's exactly the same steps that we had before. So you'll notice that these steps here that are written on our paper look similar because this I just copy and pasted from the last page. So step 1, dividing equals multiplying by the reciprocal, which means you will flip your second fraction and multiply it by the first. When you were younger, I believe they called this keep, change, flip because you keep the first one the same, change to multiply, and you do the reciprocal of the second. So here's our typed example here. See, we kept the first one the same. We changed division to multiply, and then we flipped this over, and that's how we got to that one. Good. Step 2, factor all polynomials in the expression if possible. If you look at this one, this is a trinomial, which means I'm going to see if I can do a multiply add chart, which if I'm giving it to you, you can. And we're going to label our ABCs, and we're going to multiply A times C to give us the multiply column, and B will give us the add column. A times C would give us 16. So we're looking for a pair of numbers that multiplies to make 16 and adds to make 10. That would be 8 and 2. And then because we have a 1x squared here, we don't have to do a box. We can just put it right into our factors, which you can see is going to be right there. Go the same thing for the bottom one. The bottom one is also a trinomial, so we're going to do a multiply add chart. Multiply to A times C, and then add to B. Oh, I said B, so I wrote B. 6. Add to 6. Good. 8 would be 1 and 8, which add to 9, or 2 and 4, which adds to 6. And then again, because it's 1x squared, we can just put it right into the factors. Our second fraction here, this is a monomial, so you can't factor it. It's just one term. And this one is a binomial. Remember, with binomials, it can either be a greatest common factor that's not equal to 1 or a difference of 2 squares. Difference means subtracting. This was adding, so it couldn't be that. Good. Now let's see. Okay, we just finished step 2. Step 3, if there are any matching factors in the numerator and denominator of any fraction, these will cancel out because anything divided by itself is 1. So we're trying to simplify now. If you see, we have an x plus 2 and an x plus 2. Then we have an x plus 4 and an x plus 4. Good. Step 4, multiply across the numerator and denominator to create one large simplified fraction. So in the numerator, I have 1 times x plus 8 times 1 would just be x plus 8. And on the bottom, I have 1 times 1 times 1 is just 1. Remember, if you have a denominator of 1, you don't have to write it down. So x plus 8 would be our answer. And then step 5, I just realized I numbered these wrong. And then step 5 says, lastly, find all values of x that make the denominator equal to 0. Solve each factor for x, as that is where the expression is undefined, meaning x does not exist in the domain. So we're looking for whatever could make our denominator equal to 0. Obviously, for this one, we don't have anything that could make the denominator equal to 0 because there's no variable down there. That 1 is a constant term because it's just a 1. So there's something we could plug in. So we don't have any restricted values. That means this equation exists with a domain of all real numbers, basically. Also, could we fix this over here? I guess we could say end of step 1, end of step 2, end of step 3, step 5. You know what? Just leave it alone. I'll figure it out. Okay. Anyways, see if you can do this one and then come back and we'll check it. I want to give you a hint before you go. You will have to take out the greatest common factor on 3 of the 4 parts of the fraction. Okay, here's number 1. If you want to go ahead and check. Remember, our first step is to keep the first fraction, change to multiply, and then flip the second one. You can see that right here. And then step 2, factor everything if possible. Here, I took out a greatest common factor from 3 of our 4 binomials. This one, it couldn't be factored because its GCF was just 1. If we took out a 1, it would still just be x plus 5. So that's right here. And then our next step, step 3 says if there are any matching factors in the numerator and denominator of any fraction, these will cancel out. I was able to cancel out a x plus 5 on the top and the bottom, and then also a 3 on the top and the bottom. I just realized I forgot to put my little ones from dividing. There we go. And then I multiplied across the top, multiplied across the bottom. Across the top, I had 2 times 1 times 1 times x minus 1 is 2 times x minus 1. On the bottom, I had 1 times 3x plus 1 times 1 is just 3x plus 1. And that's the answer. Remember, I do give extra credit on our practices if you want to remultiply completely. Here is what you would have if you were to remultiply to standard form. Standard form just means we don't have any more parentheses. And then for our restricted value, remember that's whatever makes our denominator equal to 0 because you cannot divide by 0. It doesn't exist. All we do is just set our factor in the denominator equal to 0 and solve for x. This is the first time we've had a fraction. Remember, you're always just going to do the opposite of what's already happening. We were adding 1, so we subtracted 1. And then we were multiplying by 3, so we divided by 3. And that got us negative 1/3. And there we go. Let's go to the next one. Okay. Actually, let's do, be a good way to split these up. Let's do 2 and 3. So pause, try 2 and 3, and then come back. Just a heads up on 3, we'll have to do a multiply add chart for this one, and then this is a difference of 2 squares. The rest are greatest common factor. Okay, I'll see you in a few. Bye. Is number 2 and number 3. If you want to glance over them, make sure you got them correct. On number 2, we already had one that was factored up in that top left of that first fraction. The denominator of the first fraction had a GCF of 4. And then our second fraction, we flipped it over, obviously. And then the denominator of our second fraction had a GCF of 3. And that got us to here. And then we were able to cross out x plus 3 and 3. And that left us with x minus 1 on the top and 4 times x plus 4 on the bottom. Then I set my denominator equal to 0, my 4 and my x plus 4. Obviously, 4 is a constant term. It's never going to be able to turn into 0, so you're good there. And then this one right here, if we were to plug in -4, that would make that 0. So that's our restricted value because our graph cannot exist where the denominator is equal to 0. And then this one here, to get your extra credit, you would just remultiply out that 4, and that would give us 4x plus 16. And then number 3, nothing could be factored in our first fraction, just the second one. The second one, we obviously flipped it over, and then our numerator was a difference of 2 squares, and our denominator was a trinomial, so we did a multiply-add chart. Once I factored those, the numerator gave me x plus 7 and x minus 7, and the denominator gave me x plus 7 and x minus 6. And then I crossed out what I could, so my x minus 6 is canceled, and my x plus 7 is canceled. So I had x minus 7 over 5x left over. This is already in standard form. There's already no parentheses. So there's no way to remultiply that for extra credit. And then here, this one, my restricted value is 0 because my denominator is a monomial. It only has one term. There's not like a plus or minus anywhere. If I were to plug in 0 here, that would automatically make my entire denominator equal to 0. You're going to see that a lot in our next section of solving equations. Okay, we just got 2 left, so go ahead and pause, try these 2, and then come on back when you're ready to check it. Here is 4 and 5. On number 4, our first fraction was actually already factored. Our second one, after we multiplied by the reciprocal, we had a trinomial on top that needed a multiply-add chart, and the bottom was a difference of 2 squares. So I just wrote my multiply-add chart over here, and then I showed my squares over here. And I wrote down my answer. From there, I simplified what I could. We had x plus 5s that crossed out and x minus 4s. And that left me with x minus 6 over -3 times x plus 4. And then I set the denominator equal to 0 to find what my restricted value was. There's only one. It was at x equals -4. And just realized I didn't put down the extra credit part. So if you were to remultiply, you would end up with x minus 6 over -3x minus 12 on the bottom there. And then on number 5, this one actually, almost everything canceled out, and we were just left with the whole number 4. So we had no restricted values because we're just looking at the whole number 4. And we got that because our first fraction had a GCF of 4 on top, a multiply-add chart on the bottom because it's a trinomial. Forgot to label my ABCs there. There we go. And then our second fraction, after we multiplied by the reciprocal, had a difference of 2 squares on top, and the bottom was not able to be factored. And there we go. Hope this helped. Bye.